All right, so this is from section 5, topic 10. I think I told y'all last class that I am skipping around in this section because I'm trying to get it finished before break. And so we're really supposed to be in section 6 by now, so I'm cutting things out that I'm trying to cover what I think is most important, basically. And the topic is systems involving a circle and a line. Systems involving a circle and a line. So we've solved systems before, systems of two lines where they intersect. I taught you how to solve them by graphing. Graph the two lines where they intersect your solution, right? I taught you how to graph using substitution, and I taught you how to graph using elimination. Today, we are going to solve a system, but it's not going to be two lines. We're going to have a circle and a line. So we're going to find out where the circle and the line intersect. And today I'm just going to show you algebraically because it's a C day and it's a short class. And then next class I will show you how to solve them by graphing as well, okay? Because we might not remember how to graph a circle, which you were supposed to have learned in geometry and maybe algebra 1. And we don't have time to cover that today, so we'll do that next class. All right? So, example 1. And the system or the method that I'm going to teach you today is using substitution. So we're going to solve the system using substitution. So remember, when we have a system's more than one equation. You usually see that little bracket next to it. And so my first equation is x minus y equals negative 5. And the other equation is x squared plus y squared minus 10x minus 12y equals negative 45. Which equation do you think is the line? The top one. That's a standard form of a line, right? ax plus by equals c. So the top one is a line. And what do you think the equation is of the bottom one? The circle. So a lot of you are probably going, but it has x squared, so that's a quadratic. Well, quadratics don't also have y squares in them, okay? So when you see your x is squared and your y is squared, that makes a circle when you graph it, not a parabola. That's a circle. So first thing we're going to do is we're going to take our linear equation and we're going to solve it for y if it's not already, okay? So solve the linear function for y. So I could either add y to both sides, but I like my y to be on the left. So I'm going to subtract x from both sides. And on the left side, that leaves me with negative y equals negative x minus 5. Have I solved for y? No, what do I have to do? Divide every term by negative 1 because you want to solve for y, not for negative y. You could also multiply every term by negative 1. The result's the same, okay, when you're talking about a negative 1. So we get y equals x plus 5. So that's the slope-intercept form of the equation, the linear equation. So now what we're going to do is we are going to substitute into the circle wherever we see a y. We know y is equivalent to x plus 5, okay? So wherever we see a y, we're going to substitute x plus 5 in its place, all right? So let me write a little direction here. Substitute x plus 5 into the circle function for y. Now, you're not going to plug in x plus 5 for every function. That's just, in this function, it's x plus 5. If y was equal to 2x minus 3, then you substitute in 2x minus 3. Okay? So I'm going to go back and I'm going to write that circle function first, just the way it's written. And be very careful not to write anything incorrectly, because that's what messes us up a lot of the times. We copy the problem down wrong. And now I'm going to go back, and wherever I see a y, I'm going to put parentheses. So if x squared plus y is being squared, that means the whole thing. The x plus 5, the whole thing's being squared. So I need a little extra space. Minus 10x minus 12 times y, so it's 12, open parentheses, x plus 5, close parentheses, equals negative 45. So that looks crazy, but we know how to do every single piece of it. We know what to do. So first, let's get rid of the parentheses. X plus 5 quantity squared. Does that mean x squared plus 5 squared? Does it? What does it mean? Doesn't it mean x plus 5 times x plus 5? Right? So bring down that first x squared. I'm going to rewrite that without the exponent. I'm going to write it as x plus 5 times x plus 5 minus 10x. And then to get rid of this parentheses, can't I distribute the negative 12? So that's negative 12x minus 60 equals negative 45.
Now what are you doing with that x squared at the beginning? Is it like multiplied by x plus 5?
Well, this x squared, I just brought it down from the original right now, because right now all I'm doing is wherever I see a y, I'm putting in x plus 5.
I'm talking about the third equation now, the new one. Is that x squared plus?
Oh, yes, thank you. I forgot my plus sign. Thank you. So now to get rid of, don't start combining like terms yet, because we still have parentheses. And so to get rid of these parentheses, I'm going to have to distribute, right? So let me bring down this x squared plus x times x is x squared. X times positive 5 is positive 5x. Then move to the inside 5. 5 times x is positive 5x. And 5 times 5 is positive 25. And everything else, I'm just going to be careful to bring it down like it's written, not leaving anything out. Now I can combine like terms, okay? So your squared terms, be careful. What is x squared plus x squared? 2x squared. A lot of people say x to the 4th. That's x squared times x squared. All right, let's combine our linear terms. 5x plus 5x make 10x. 10x minus 10x make 0x. 0 or 0. 0 minus 12x is, so minus or negative 12x. Okie dokie. Let's do our constants. Positive 25 and negative 60. Negative 35. I cannot combine that negative 45 right now because it's on the other side of the equation. Okay? So if I want to combine it, I got to add it to both sides to bring it over. So that gives me 2x squared minus 12x plus 10 equals 0. Now I'm trying to solve the system. I want to know when the line and the circle intersect, so that's going to be ordered pairs on a graph, right? So I need to solve for x. Well, notice I just created a quadratic equation. Do we know how to solve a quadratic equation? Yeah, we do. We know we can factor it a lot of the times, not always. We can solve using the quadratic formula every time. We can solve using completing the square every time, right? So let's make a little note. Solve the quadratic function by either factoring, quadratic formula, I'm going to abbreviate, or completing the square. If you're not going to remember what those abbreviations are, just write the whole word down. So I'm going to try factoring first, and if that doesn't work, then I'd probably go with the quadratic formula. So if I'm going to factor, we always look for a GCF. Do we have a GCF? Yes. Yes. What is it? 2. So we're going to factor it out. So remember, we put the GCF outside the parentheses, and we divide each term by the GCF to see what's left. So 2x squared divided by 2 is x squared. Negative 12x divided by 2 is negative 6x. Positive 10 divided by 2 is positive 5. So let's determine A, B, and C. We're not looking at the original now because that's not what we're factoring. We're factoring what's left after we took out the GCF. So A is 1, B is negative 6, and C is positive 5. Make my little T-chart. Am I going too fast? Okay. I need two numbers that multiply together to get AC. A times C is positive 5. And on the right side, I need two numbers to add together to give me B, which is negative 6.
2 and 3.
All right. 2 times 3 is 5. 2 plus 3, I'm sorry, bless you. 2 times 3 is 6. 2 plus 3 is 5. All right, let's try that. Negative 1 times negative 5 is positive 5. Negative 1 plus negative 5 is negative 6. And that works, right? We're not always going to find it on the first time or the second time, maybe the third time, the bigger the factors are. So you just keep going till both sides work. You can't say it's not factorable until you've tried every possible combination of factors. And then you can say it's not factorable. But this one is. So we have 2 times in your parentheses. I'm going to have an x minus 1 and an x minus 5. Do I need to divide and slide on this one? No, because A is 1. I divide or slide by 1, it's not going to change anything, right? But, so I'm factored, but I haven't solved. So I have a GCF of 2. If I set 2 equal to 0, is that going to give me a solution? No. So 2 is a GCF, it's not going to give me a solution. If I set x minus 1 equal to 0, what does x equal? 1. If I set x minus 5 equal to 0, what does x equal? 5. So I want to know where this circle and this line intersect. I need ordered pairs. My answer is not 1, 5. Those are both x's, right? So I have found part of 2 ordered pairs. One that has an x value of 1, the other that has an x value of 5. How am I going to find their corresponding y values?
Plug the next one,
Into what?
the equation.
Which one?
The first one, the line.
Okay, so when I was making my notes, because I always make my notes first, I wasn't thinking, and I accidentally plugged x equals 1 into the quadratic that I made. But I'm not graphing a quadratic. It just so happened when I combined them two together, it made a quadratic, but that's not what I'm graphing. I don't want to plug it back into there. I need to either go back to the original, like you said, either the line or the circle, not the quadratic that I made. Would you choose to plug it into the circle?
No.
I wouldn't. Could you? Yeah, we'll get the same answer. I would definitely choose the line though. That's going to be a lot less work. So I'm going to have to substitute each of these values into either original equation. So I have to do it separately. I've got to substitute x equals 1, and then I'll do x equals 5. So I'll start with x equals 1. And like I said, I'm going to substitute that into the linear function. So wherever I see an x, I'll substitute in a 1. And then just solve for y. So one of my ordered pairs where they intersect is at 1, 6. But I know they're going to intersect 2 times because I had that second solution for my quadratic. So I have to substitute that value in as well. So if I were to graph this, my graph would be something like I would have a circle and my line would intersect it at 2 places. So this would be like 1, 6 on the graph, and this would be like 5, 10. Could you have more than 2 solutions when you have a system with a circle and a line? Could you have more than 2 solutions? Is this line going to bend and turn around and cross the circle again? No. Could you have just one solution? Yes. How would it be that you only had one solution?
It's like on the edge of the line.
Yeah, do y'all remember what that's called when your line just touches the circle once, it just skims past it? Do y'all remember what that's called? When they are blank to each other? Starts with a T. Tangent. Yeah, if you have the circle and the line is tangent to it, that means it just skims it, it just touches that one space. That would give you one solution. Or could you have no solutions? Yeah, say you have the circle here and the line is way up here or down here or goes like that. It's never going to intersect it. You could have no solutions, right? But in this case, we have 2 different solutions, 1, 6 and 5, 10. How about that? It's fun, wasn't it? Okay, I want to try real hard. I've got one more example. To get through the second example, we do the exact same thing. To try to get through it before the bell rings. Okay, and I'm not giving you homework. So I'm going to go ahead and start it. If you need this at the end, you can look at my notes if you missed something, okay? All right, example 2. Solve the system algebraically. And I am recording this, so I'll post it on Edmodo if you need to go back over this tonight. Feel free to rewatch the video of the lesson. We have x squared plus y squared. So that right there, I know it's a circle. Plus 29x plus 3y plus 152 equals 0. So that's my circle. And then we have x minus y equals negative 2. We know that's my line. Which one did we start with on the first example?
The line.
The line. And what do we do with a line? We put it in slope-intercept form, right? Or isolated the y. We're going to do the same thing this time. So if I want to isolate the y, I'll subtract the x from both sides. That gives me negative y equals negative x minus 2. Divide every term by negative 1 or multiply every term by negative 1. And y equals x plus 2. What do we do with that? Plug it in the circle, right? Wherever we see a y in the circle function, we're going to substitute an x plus 2. We're going to replace y with x plus 2. So I'm just going to rewrite it as it was given to me to start off with. So I have it right there. Wherever I see a y, I'm going to put parentheses, and inside the parentheses, I'll put x plus 2. That x plus 2 quantity squared, do not do x squared and 2 squared. It means x plus 2 times x plus 2. If you do that, you miss out on the middle term. So be very careful about doing that. You don't want to do everything right and mess that part up. And I am going to go ahead and distribute the 3 times the x plus 2. And then I'm going to distribute to get rid of these parentheses. So I have x squared plus x squared plus 2x plus 2x plus 4. So that got rid of the parentheses, and everything else I'm just going to bring down for now. Plus 29x plus 3x plus 6 plus 152 equals 0. Now what do we do? Combine like terms. I have x squared plus x squared is 2x squared. 2x plus 2x is 4x plus 29x is 33x plus 3x is 36x. And then 4 plus 6 is, and 10 plus 152 is 162 equals 0. Alright, I created a quadratic again, right? We know how to solve a quadratic. I can try to factor, or I can use the quadratic formula, or complete the square. I'm going to start with factoring. Is there a GCF? What is it? 2. And I'm going to speed this up because time's a ticking. So if I factor out a 2, so we know we divide every term by 2 when we factor out a GCF. That gives me x squared plus 18x plus 81. So I know A is 1, B is 18, C is 81. So in my T-chart, I need two numbers that multiply together to give me AC, which A times C is positive 81. And I need two numbers that add to give me B, which is positive 18. Any ideas? Alright, let's try it. 9 times 9 is 81. 9 plus 9 is 18. That works. So I've got 2 times x plus 9 times x plus 9 equals 0. Do I need to divide and slide? No, because A is a 1. So I have two identical factors. What does that tell me about what the quadratic was that we started with? It is going to be a tangent line. That is very true. We know that because we're going to get one solution, right? What kind of problem? This was a special case. What was it? Perfect square trinomial. If we would have recognized that from the beginning, we wouldn't have to go through the T-chart and divide and slide. We could have just made the one set of parentheses square it, you know, perfect square trinomial. Regardless, 2's not going to give me a solution. X plus 9 and x plus 9, they're going to give me the same solution. What is it? Negative 9, right? And yet, that would be a tangent line. If I drew the circle and the line, they're only going to intersect at one place. There's two solutions, but they're the exact same. So I don't need to find both solutions, okay? So that's my x value of the ordered pair. How do I find the y value? Either original. Does it matter which one? No. So I'm going to use the line. But I got to be careful. Oh, wait. No, I'm thinking of that. So x is negative 9 minus y equals negative 2. So I just solve for y. So the ordered pair that the circle and the line have in common is negative 9, comma, negative 7. Tomorrow I can show you how to graph that, and we'll see that they do actually intersect in one place because they're tangent at negative 9, comma, negative 7. Does anybody have questions about that? We finished that one fast. So again, if factoring doesn't work, use the quadratic formula. Use T-chart, divide, and slide. If we get imaginary solutions, what do you think happens graphically? They don't intersect, right? Okay, so I'm going to pause this so I can go ahead and save it. If anybody needs my notes, let me know. I've got two separate copies. Here's one of them. I've got another one over here. If y'all can share if you need to. Just make sure you get both of them back. Oh, what did I do? Am I still going?